Their consumption of dietary fibers are significantly higher, maybe 80 grams. Some reports appear that media labs are speaking about healthy control.
袋入り。
はい、ありがとうございます。726円でございます。
Control the disease individual versus a Westerner. These are really subtle differences between those versus when you go find somebody who lives in a more rural environment who consumes much more higher levels of dietary fiber. They're going to be significantly different and much more easier to prove diseased versus healthy individuals. Thank you.
Yeah, maybe I'll take it right now. I mean, points well taken. First of all, what is the definition of healthy? It's always relative, and it's possible none of us are truly healthy at some level definition. I think one thing we are doing, your point's well taken, Western diets are generally, and Justin Sonnenberg, I'm sure we'll talk about this is one of his big mantras, the Western diet is very poor in fiber compared to other groups. And one thing we are doing with Justin as part of our HED project, we actually have people doing a number of fiber perturbations. Those data came late in the study, so they're sitting there, and we hope to analyze them. They're getting analyzed in a more superficial fashion now, but hope to dig deeper. So I do think we need to tear that apart and do analytical chemists. So that people do these things now, they still throw in complex mixtures. I would argue it'd be nice to know exactly what each fiber is doing to each individual, so we can personalize this. And that is not being done as far as you tell, at least in a systematic, broad systematic fashion. And even the combinatorics are quite large, right? You have lots of people, lots of different individual microbiomes, and you want to have lots of different fiber types. Some have short chain, long chain, hydrophilic, etc. Really, the positive negative fibers combinations are very large. But I do think those studies need to be done so we can know exactly what an individual fiber does or an individual other supplement to each person and personalized diets that way. That's my belief.
Yes, Lincoln Tom from Rutgers. So it's exciting to see that we start to have longitudinal multi-omics data set. And so there's going to be a huge opportunity for knowledge discovery. But if you look at the data set, they are still the so-called big small data. So you have a huge number of variables, but a limited number of samples. And also the data set has a high scarcity, so a lot of zeros because of the individual difference. So it's very important to have a really meaningful way to reduce the dimension. So the first attempt would be taxon-based analysis, but we know it's actually not right to gather the data at a different taxon level because we are lumping all different things in one new data set. So what would be a biologically or ecologically meaningful way to reduce the dimensionality of the data so that we can really go after such kind of data set?
I think we all have an opinion on this one, so probably both responses here. I think don't underestimate the power of longitudinal data. Yes, it's a small number of individuals. In most cases, we're looking for deltas. We're looking for changes across the situation with IBD, whether it's pregnancy or in our case, whether it's what's happening in viral infections for pre-diabetes versus not. And that really empowers you in a way that you may not appreciate. You can be very statistically robust for individuals, and you don't necessarily need large N if you're following perturbations of similar sorts across similar individuals. So you can easily tease out significant responses. So I think that is the power of the studies we're doing. So the fact they are longitudinal really does give you an empowerment. It's very different. You have to shake this whole GWAS 100,000 case, 100,000 control mentality to appreciate the power of what we're doing, I believe.
I can't add much to that, except to think on a continuum from large-scale epidemiology-style studies where you're targeting many individuals, usually cross-sectionally, usually relatively shallow data, down to very small-scale like model system studies in great depth, HMP2, and leave a very quick economic by design somewhere in the middle, so that it's targeting quite a bit of depth in a medium-sized population, with the hope of getting the best of both worlds as we move the microbiome more towards detailed mechanistic understanding.
Just hoping that you at least comment on, that even if the data is sparse, which we would all agree on, it's still that there's lots of opportunity for it to be statistically robust, right? That's fair, right?
When you see a lot of information at the pathway level, even if you can't get it down to the individual molecule level, if you're underpowered that way as well.
Yeah, to echo what Owen said, there are of course methods for working with data that are of the wrong dimension and sparse, not statistical as well.
Hi, Peter Carmelli, Susan. I guess I'm wondering, so it seems like a lot of the resources, both financially and just in terms of time, as sort of mentioned, P1 and 2 has been the sample collection and establishing these huge biobanks that you guys all have access to. So I'm wondering, what is there some sort of plan moving forward to make those samples available, either to people that are part of this consortium or the broader research community that might be developing new technologies to analyze those initial samples or the nucleic acids or other downstream materials?
I can speak for phase 1. You'd have to collaborate with one of the clinical centers that's collected the samples. So if you're interested in DNA extracts from the Healthy Cohort study from phase 1, and there's not a lot of them left, but there are some, I would recommend you contact me directly.
I guess I'd like to go a little meta on your question, though, which is like if we think about every presentation that we're going to see today or anything that's funded by NIH, it's one opportunity that's out there is it'd be very nice to have essentially kind of a PI registry where you could ask the question, okay, you've published this, but are the subjects available for consent, or are the samples available that you can pull up with whatever resources are associated with it? Because that's another thing that there's just a tremendous loss between all that those incredible rich resources that potentially may be available in any SRA or not to be about that data as well in any public repository if that's not explicitly stated in those repositories.
So just to echo what everybody else is saying, we have probably the biggest biorepository of data from HMP2 study. Samples that are stashed away in our biobank, or it's called the Research Alliance for Microbiome Science Registry. We did that with the idea that we would leverage those into future studies in our own group and in collaboration with others. And we're very willing to do that. The issue is the maintenance of this facility and the interaction. We don't have financial resources for curating and processing these samples so that we can distribute them or have any kind of way to do that yet. We're trying to work on something like that, but at the moment we don't have that. If somebody does want to have a collaboration with us, we're happy to talk about it.
To wrap it up, I don't want to cut into lunch hour or actually more importantly maybe the poster session. So the first, there's 3 poster sessions, one each day, 40 posters above in the atrium. So make sure and visit the posters. If you ordered lunch, I think you have to ask the registration desk where you pick up the lunches. I believe they're down here on the lower lobby. That tent, that big white tent out there on the natural lawn is ours. So go out there, enjoy yourself, network with people you haven't met before, and come back at 1 o'clock.
Okay, everyone. Welcome back from lunch. I like to be right
right on time, so we're already 3 minutes late. That's causing me stress. I wonder what that's doing to my microbiome. Okay, so this session is, sorry, I should introduce myself. My name is Lisa Chadwick, and I'm a program director at the National Institute of Environmental Health Sciences, where we are interested in how the microbiome interacts with environmental chemicals. And if you would like to be interested in that too, feel free to find me at this meeting and talk to me about it. So in this session, we're going to be talking about the tools, technologies, and approaches for microbiome research that go beyond sequencing and try to identify what are the big needs, gaps, and challenges in that area. So we'll have a session just like we had the last one, where we'll have 4 talks right in a row, although we're going to have one talk, one sort of mega tag team talk, and then another talk, and then we'll have a joint Q&A session at the end. Our first talk is from Katie Fowler from University of California, San Francisco, and you can come up here. Your slides should show up. Timer working? Do we know? Okay. Great. Hi, everybody. Welcome back from lunch. I wanted to start by putting up a picture that represents what I think a lot of the work on microbiome science has been to date, especially any science related to the human microbiome and hopeful translational work, which would be you have a patient with symptoms, you gather some biomolecules, and we count up the percentage of sequences that come from each microbe or from each gene, make these stacked bar plots or pie charts, and then try to associate that with what's going on with the patient. And as we know, many interesting associations are detected. What I'm interested in is moving beyond these associations towards mechanism and trying to understand what's going on at a genetic level in the microbes that would be explaining those associations and what associations might be missing with these stacked bar charts and pie charts. The reason I'm worried about this is that even if we can characterize microbes at the level of individual species, we know that different examples of that species, different populations of cells, have different genes. And this touches on what Howard spoke about in the keynote about what is a species anyway. We're interested in the same question. And we know, all of us, from looking at genome sequences, that the gene content differences are different across different strains of the same species. And my lab developed a tool to quantify that using shotgun metagenomics data. So we took 2 people from a variety of studies that were available in the public domain, and we asked for the sequences that represent a given species that are shared between the 2 of them, what percentage of genes are they sharing. And here's an overview of the results. So the horizontal axis is what percentage of genes are shared across people, so each dot is a pair of people, and these are organized by the different species. And you can see that there's a lot of variation, with some species having only maybe 10% gene content difference, but some of them having up to 40, 45, even 50% of their genes different between 2 people who harbor the exact same species. And of course, if you go up to gene into a higher taxonomic level, that's even larger. And we then looked to see whether the gene content was organized according to where people were from. And the answer is it depends on the bug. So for some bugs, there are these huge differences between gene content. It has nothing to do with where someone's from. There's basically a big star phylogeny, and the different strains get everywhere. And Howard's talking about the question about, we got into talking about dispersal limitations, whether there's barriers to gene flow. For some species, there seem not to be. Whereas for others, like Erectile that I'm showing here, there's a lot of structure with plates based on either the SNPs, the nucleotide differences in their genome, or in their gene content, really organizing by continents. However, but with some sharing of these 2 clades here between North America and Europe. The other reason that I'm worried about getting down to a genetic level rather than a taxonomic or a gene level description of the microbiome is that even when you have the same species in 2 people and you look at genes in the core genome that are shared, so we have the same species and the species has the same gene, those genes harbor genetic mutations, some of them that make functional differences in what that gene is doing. So these are different species. This is Human Microbiome Project data, and in red are between host differences. So across these different base pairs, there's a genetic mutation between people, and even within hosts, we see genetic variation maybe every version as someone else and not being able to necessarily handle the size of that data on their own computer, but sitting there with high-speed compute that you can spin up, and lots of users can now be looking at the same data and running analyses in the cloud and creating annotations, especially through multi-omics studies that get at function, curation of that data, and then adding curation back up into the cloud for other people to see. So this is right now a little bit of a pipe dream, but we heard some great steps in that direction from Owen and others this morning, and I think this is something that NIH could really tackle, and I want to make a pitch for it today.